There is a bird in New Zealand that smells like a dessert menu. Sweet honey. Old violin cases, fresh lavender. If you walked past it in the dark forest, you might think someone had left a candle burning nearby, or that a beehive had somehow wandered into the undergrowth. But there is no candle. There is no beehive. There is only a fat, flightless, nocturnal parrot called the kakapo, sitting quietly in the moss, radiating a scent so specific that scientists have spent literal careers trying to bottle it. This is not an exaggeration for a YouTube title. Trained researchers on the record have described the kakapo's smell as a mix of lavender, honey, and dust. Others compare it to the inside of an old, slightly damp violin case. New Zealand biologists at Massey University settled on the phrase Swedish and vegetative. A poet who spent time around the birds went even further, describing the aroma as something between honey, papaya, and an old, well-used clarinet case. Here's the strange part. This isn't a random fluke of biology, like how some people just happen to have body odor. The kakapo's smell is not an accident. It is one of the most sophisticated pieces of evolutionary engineering in the entire bird kingdom. And the same trait that makes this animal so magical, so memorable, so weirdly lovable, is also the exact trait that nearly wiped it off the face of the earth. By the end of this video, you'll understand why an animal would evolve to smell like dessert, why that decision worked perfectly for millions of years, why it turned into a death sentence the moment humans showed up, and how, in one of the strangest twists in conservation history, scientists figured out how to turn that same smell into the bird's greatest defense. So let's start with the obvious question. Why does this bird smell like this in the first place? To understand the kakapo's smell, you have to understand what it's like to be a kakapo. This is the world's only flightless parrot, and also the heaviest parrot alive, with some individuals tipping the scales at nearly 9 pounds, more like a well-fed cat than a bird. It cannot fly. It survives by walking, climbing, and hiding, and critically, it does almost all of that at night. New Zealand, before humans arrived, had no land mammals at all. Not one. No cats, no rats, no foxes, no weasels, nothing with fur and a nose walked those forests for millions of years. The only real threats to a kakapo were birds of prey that hunted by sight during the day, animals like the now extinct Haast's eagle. So the kakapo's ancestors made a very reasonable evolutionary bet. Go nocturnal, stay still, and blend into the moss. Its feathers are a mottled yellow-green, practically a paint sample lifted straight from a forest floor. When startled, a kakapo's instinct is to freeze completely, trusting its camouflage to make it invisible. But there was a problem hiding inside that solution. If you're active at night, in thick, tangled New Zealand forest, and you're too heavy to fly from branch to branch to find a mate, how do you locate another kakapo in the pitch black? You can't rely on sight. Sound only carries so far, and it gives away your position to predators too. So, evolution reached for a different tool: smell. Kakapo have one of the most powerful olfactory systems ever measured in a parrot. Researchers studying kakapo brain anatomy found they possess an unusually large olfactory bulb, the brain region dedicated to processing smell, along with the highest number of what are called mitral cells recorded in any bird species studied to date. Mitral cells are the neurons that carry a scent signal from the nose into the rest of the brain. More mitral cells generally means a more sensitive, more detailed sense of smell. To put a number on it, one anatomical study measured the kakapo's olfactory bulb ratio, essentially comparing the size of the smell processing region to the size of the whole brain, at just over 30. A typical parrot, like a rose-ringed parakeet, measures around 10. That means, proportionally, a kakapo's brain devotes roughly 3 times more real estate to smell than an average parrot's does. This is where the honey and violin case scent comes in. That distinctive musky, sweet, slightly funky odor isn't just body odor in the human sense. It's a chemical signature, a calling card the bird leaves behind wherever it goes. Because kakapo are solitary, wandering alone through dense forest at night, that scent becomes a trail. Follow the smell, find the bird. And it gets more specific than that. Kakapo have an incredibly unusual mating system for a parrot, actually, for any bird, called lek breeding. Male kakapo don't defend a nest or a territory with food. Instead, they dig out a network of shallow bowls and cleared paths in the forest, called a track and bowl system, which work almost like a natural amplifier. From inside these bowls, males produce a deep, low-frequency booming call, night after night, for weeks or even months, trying to summon females from across the island. Females, meanwhile, wander from arena to arena, essentially window shopping, evaluating different males before choosing a mate. And here's the fascinating detail researchers uncovered. Scent seems to be part of that evaluation. Studies analyzing the chemical makeup of kakapo feathers found that males who are actively booming, the ones putting real effort into courtship, produce a noticeably more complex, more chemically diverse scent than males who aren't participating that season. Female scent, by contrast, stays fairly consistent all year round. In other words, the male's smell might be functioning almost like a resume, broadcasting information about his condition, his health, his reproductive readiness. Some males, according to people who've worked closely with the recovery program, are so popular that females will queue up and wait for their turn even when other males are available nearby. This isn't guesswork either. Scientists have physically tested it. Researchers clipped around 60 feathers from live kakapo during routine health checks and transmitter changes, then shipped them to an olfactory chemist in Arkansas, who ran them through a gas chromatograph mass spectrometer, a machine built specifically to isolate and measure volatile scent chemicals. To go even further back in time, the same team tracked down feather samples collected from kakapo in the 1880s, now stored in a museum in Vienna, so they could compare how the bird's chemical signature may have shifted over more than a century. The kakapo's nose isn't just for romance either. It's also a foraging tool. This bird has been documented distinguishing between different food odors while searching for ripe fruit from rimu and pink pine trees, a skill that's been formally documented in only one other parrot species on the planet. So to summarize the biology, in a world with no mammal predators, being nocturnal, flightless, and drenched in a powerful, traceable scent wasn't a flaw. It was a finely tuned survival and mating system, refined over millions of years of isolation. The kakapo built its entire existence around a simple assumption: nothing that hunts by smell is coming for me. That assumption held up for millions of years. And then it didn't. Everything changes with the arrival of mammals. For most of its evolutionary history, New Zealand was essentially an island laboratory with the predator category left blank. No mammals meant no smell hunters. A kakapo could produce the strongest, sweetest, most detectable scent imaginable and pay zero price for it, because nothing on the islands had the biological hardware to track it. That changed roughly 700 years ago when Polynesian settlers arrived, bringing with them two mammals that had never set foot in New Zealand before: the kuri, a domesticated dog, and the kiore, a small Pacific rat. The kiore in particular spread rapidly and began preying on kakapo eggs and chicks. Then came European ships. Cats arrived from 1769 onward, initially brought aboard as vermin control, and by 1820, feral cat populations were already established and spreading across the islands. Two more species of rat came ashore as well. Forests were cleared for farmland, shrinking kakapo habitat even further. But the single most catastrophic decision came in the 1880s, and it's almost darkly comic in hindsight. European settlers had earlier introduced rabbits to New Zealand for food and sport. The rabbits, with no natural predators and endless farmland to eat, exploded into a plague, devastating pastures across the country. So the government's solution was to import a predator that could control the rabbits: stoats, weasels, and ferrets, shipped in by the thousands. One newspaper account from 1884 described a shipment of stoats that survived a stormy sea voyage to New Zealand and were released onto a farming estate. Within hours, according to the report, a single stoat had already traveled miles away and killed 7 ducks. Between 1883 and 1892 alone, close to 7,800 stoats and weasels were released across the country, specifically targeting rabbit-infested pastures. The problem was that stoats aren't picky eaters, and rabbits, unlike a slow, flightless, heavily scented parrot, are actually fast and difficult to catch. A kakapo, sitting frozen in the moss, radiating a smell that carries for meters, wearing an evolutionary defense mechanism built entirely around fooling eyesight rather than a nose, was, from a stoat's point of view, the easiest meal in the forest. This is the fatal flaw in full effect. The freeze and camouflage strategy that had protected Kakapo from sight-hunting birds of prey for millions of years did absolutely nothing against a predator that could smell them from yards away, day or night, whether the bird moved a muscle or not. The kakapo's greatest asset, the trait that let it find mates and locate food in complete darkness, had become a homing beacon, actively broadcasting its location to the very animals now hunting it. The numbers tell the story with brutal clarity. On Stewart Island, researchers surveying kakapo deaths found that feral cats alone were killing the birds at a rate of 56% per year. 56% annually. At that rate, no population can sustain itself. A bird that had once been, according to fossil evidence, New Zealand's third most common species was reduced by the mid-1990s to just 51 known individuals left alive on the entire planet. The nesting process made things even worse. Female kakapo raise chicks completely alone, with no help from the male, and they have to leave the nest every night to forage for food, sometimes for hours at a time. That leaves eggs and chicks unattended and defenseless. And because chick rearing stretches on for months, the nest itself gradually becomes soaked in that same sweet, musky scent, turning it into an easy, obvious target for anything hunting by smell. There's one story from this era that captures the tragedy perfectly. In the 1890s, a pioneering conservationist named Richard Henry attempted the first serious kakapo rescue effort in history. Using a muzzled dog named Lassie, trained to sniff out kakapo rather than harm them, Henry personally rowed several hundred birds across open water to Resolution Island, a supposedly predator-free sanctuary in Fjordland. It was the first documented use of a scent-tracking dog in conservation anywhere in the world, decades ahead of its time. For a while, it worked. And then, in 1900, a single stoat swam to the island. Henry spent 91 consecutive days trying to trap it. He never succeeded. The predator population on Resolution Island slowly rebuilt itself, and the kakapo population there began to collapse all over again. The very scent that had made Henry's rescue dogs so effective at finding kakapo to save them was, in the surrounding forest, doing the exact same job for the stoat trying to kill them. By the middle of the 20th century, the kakapo had become something close to a ghost story. Between 1949 and 1973, New Zealand's Wildlife Service ran over 60 separate expeditions searching for surviving birds, mostly turning up nothing. The species that had spent millions of years perfecting the art of being found by its own kind in total darkness was now dangerously close to being found by nobody at all. In the late 1970s, a small team led by conservationist Don Merton made one last search of the remote Fjordland mainland, using tracking dogs trained to follow that same distinctive scent trail. The dogs picked up a trail, cornered a kakapo against a cliff edge, and Merton dove and caught the bird by hand. They named him Richard Henry, after the man who had tried to save the species nearly a century earlier. He turned out to be the last known kakapo ever found on New Zealand's mainland, and his genes are still part of the population being bred today. Here's where the story turns. Conservationists eventually realized something that should have been obvious from the start. If a kakapo's scent is powerful enough to guide a predator straight to it, that same scent could guide a rescuer straight to it too. The trait didn't need to be erased. It needed to be redirected. Since 1995, New Zealand's Department of Conservation, working closely with the Maori iwi Ngai Tahu, has run the Kakapo Recovery Programme, widely considered one of the most intensive single-species conservation efforts anywhere on Earth. Every surviving kakapo, and there are only around 236 of them alive today, is individually named, fitted with a radio transmitter, and tracked continuously. But the real callback to that original evolutionary flaw is the return of the scent dog, this time trained with far more precision than Richard Henry ever had access to. New Zealand now maintains a network of roughly 80 specially trained conservation dogs. About 35 of them are trained to hunt down the invasive predators, rats, stoats, feral cats that once nearly wiped Kakapo off the map. The rest are trained to do the opposite, locate the Kakapo themselves, sniffing them out in dense forest for health checks, nest monitoring, and population surveys, all without harming a single bird. These predator detection dogs have been in official systematic use since 2002, and they've proven especially valuable in exactly the scenario you'd expect when predator numbers are already low. A trap can only catch an animal that walks into it. A dog can find an animal that's actively trying to hide. One incident from 2022 shows just how seriously this threat is still taken. A single male stoat somehow managed to swim to Chalky Island, one of the last remaining Kakapo refugees. In response, the Department of Conservation launched a full-scale operation involving trapping specialists, detection dogs, trail cameras, helicopters, and boats. It took 8 months and roughly 300,000 New Zealand dollars to finally track down and remove that one animal. The alternative, officials said, would have been evacuating the entire Kakapo population from the island. All of that effort for one predator, because the danger of a smell-hunting mammal reaching a sanctuary full of strongly scented, flightless birds is still treated as an emergency, even now. The modern recovery effort has also moved well beyond dogs and traps. Because the population is so small, inbreeding has become a real threat, with a large share of eggs historically turning out infertile. So scientists now collect semen for artificial insemination, sometimes swapping a real egg for a fake decoy so the true egg can finish developing safely in an incubator, then hand-rearing chicks that need extra help before returning them to the wild. Every one of these interventions exists for the same underlying reason the scent dogs do: to give a species that evolved for a predator-free world a fighting chance in the one it actually has to survive in now. And the recovery is working. From that terrifying low of 51 birds in 1995, the population has grown roughly fivefold. Kakapo only breed when native rimu trees produce a mass fruiting event, something that happens unpredictably, roughly once every 2 to 4 years, which makes every single breeding season disproportionately important. After a 4-year gap with no breeding at all, 2026 turned out to be one of the strongest seasons on record, following the heaviest rimu fruiting scientists had measured yet. 80 nests produced over 250 eggs, and by spring, at least 95 chicks were being raised across the Recovery Islands, already beating the previous record of 73 fledglings set back in 2019. There's one more character worth mentioning before we close this out, because it perfectly captures how far this species has come, from being hunted by smell to becoming a global icon. In 2009, a hand-raised kakapo named Sirocco became internationally famous after climbing onto a zoologist's head during a BBC documentary shoot and attempting to mate with it, live on camera, while the crew struggled to keep filming through their own laughter. The clip has since been watched more than 30 million times. In 2010, New Zealand's Prime Minister officially named Sirocco the country's spokesbird for conservation. Because Sirocco was raised away from other kakapo as a chick, he imprinted on humans instead, which is technically a heartbreaking detail, since it means he'll likely never breed. But it's also exactly why he became such an effective ambassador. A bird whose species was almost wiped out by broadcasting its location too effectively is now broadcasting something else entirely. Awareness to millions of people about exactly what nearly happened to it. The kakapo's smell was never a mistake. It was a solution to a problem that, for millions of years, didn't include predators with noses. When that problem changed overnight, the same trait that had kept the species alive became the very thing pushing it toward extinction. And now, through one of the more unlikely partnerships in conservation history, humans, dogs, and the exact scent that once spelled doom, that same trait is being used to write the species a second chance.